Hey everyone, welcome to another episode of the Decentraland series. Today we have a guest, Abhishek Kumar. We'll be discussing about his Decentraland project requirements. He has recently left a comment in my video and I've invited him to go through his requirements in more details. So hi, welcome to the show Abhishek.
As usual.
Hi. Okay, can you introduce yourself to our audience?
Hello, audience. I am Abhishek, an architect from India, and currently I am working as a freelancer in 3D visualization.
Nice. So what are you looking for in this collaboration?
I'm looking for how can I import the 3D model into the central land as a fully workable building.
Okay, nice. All right. So, without further much ado, let's proceed on to loading his Decentraland model into Decentraland test environment, and then let's experience how we are able to load up custom components. In this case, we'll be showing the sliding door together with his model, and let's see how it turns out. Okay. So,
Okay. Okay.
yeah. Okay. So this is the model that Abhishek designed. So basically, it's a simple house. Okay, that's and so basically, on top of the two layers that he has added, I've added the collider layer. All right. So the collider layer is what gives the solidness to the model. So without the collider, uh, the avatar is able to pass through the buildings like a phantom, like a ghost. So we wouldn't want that, right? It's not practical. We want the avatar to have the real real solidness of the building. Okay. So for this so let's contrast the between the two with collider and without collider. So I've disabled the collider in the SketchUp and I'll export the model as a GLB file, and let's see how it looks like and how it feels like in the test environment. Okay, so before going to the exportation, you have to install the Chronos GITF plugin in SketchUp first. This is the GLB export function. Uh, okay, so so the export is successful. Let's switch over to the code. Okay, so the loading on the scene is really simple. We have the base scene object, and then in here we are loading the GLB file into the scene, and then we add the scene into the engine. Okay, it's as simple as this. Let's load up the scene.
Not simple for architects.
Yeah, that's where I come in. Yeah. Okay, let's have a look. Yeah, so the loading of the Decentraland test environment takes a while. Yeah, so you have to be patient.
Okay.
All right, as you can see, we have the avatar here. Um, but the avatar is able to pass through walls. Why? Because we don't have the colliders in place. Right? Okay. So now let's close this.
Okay.
Let's close this. Let's jump back to SketchUp and let's enable the collider. Okay. Let's re-export it. Okay. So for the test environment, every time you export a new version of a GLB file, you have to kill off the current session. Yeah. Yeah.
Okay.
So you have to restart the session. Okay, so as you can see now the avatar is not able to pass through. It's solid. So so this is the missing piece of the puzzle. So to bridge SketchUp to Decentraland, you have to do the additional work of adding the colliders. Yeah. Okay. So Abhishek, maybe you can describe in
Yes.
your SketchUp model in more detail. What are we seeing here? What are we expecting to see from this model?
I made just a simple room with one door, two windows, and I try to add a one light bulb
Oh,
also. Basically, I want to test a simplest building possible for the first
I
time.
see. So it looks like it's successful here. o-
Yes, yes.
okay. So okay. So the next part is we're gonna try to um, add a door to the entrance of the building. There's a simple sliding door. So
Okay.
this may get a bit tacky. So bear with me. Okay. So
Okay.
um, for the keys of the sliding door, we'll be using this open source code from decentraland scenes sliding dash door. So it's a public GitHub repository.
Okay.
You can take a look. Link will be added in the description below. So
Okay.
looking at this code is quite lengthy, but it's simple. What we are looking for is we are looking to add a door, and we are looking to add the material to the door, which is red with some metallic feel and roughness to it. And we'll be also adding some interactions to the door. So there's a parent door and there's a child door. The child door will be attached to the parent door. The parent door will be responsible for the toggling of the animation. So it does the sliding. So there's a state of on and off. So on opens the door, otherwise it closes the door. Um, yeah. So and also yeah, there's a pointer down that toggles the state of the door. Okay. So what we'll be doing is we'll be um, reconstructing this code piece by piece. So we understand the flow
Okay.
from start to bottom. Okay. So let's start off with adding the door itself, which is door L. Okay, just this. Okay, so door L, position 0.5, 0, 0. Okay, let's save it. Let's go back to our preview. As you can see, there's a little white square here. Yes,
Yes.
okay. So it's basically just a white square. It does nothing. Okay. Now the next
Yes.
part is we want to position. Let me see. Okay, let's add the material first. Let's define the material. So we add the color red to the door. We're still compiling. Oh, wait, let me check it out. Door material. Oh yes, sorry, I forgot to add the material to the door. Okay, let's go back. As you can see, now it's red. Okay, but it still does nothing. It's just a red piece of rectangle, a board. Yeah.
Yes.
Okay. Next, we'll be adding the vector and the parent door. Okay, so later on in the code, we'll see how to adjust the door position exactly at the entrance of the model. Okay,
Okay.
let's go back here. Okay, still nothing much. So we remove the door R. The door R is the right door. So in the initial sample code, there's two doors, the left door and the right door. But in this case, we'll just be using the left door. So just to demonstrate a single
Okay.
door. Yep. Let's go back
Yes.
here. So you can see the door has now move position to here. Okay, so what's causing the move from that? Previously it was here, right, at the corner, and now it has moved here.
Yes.
Okay, so for decentraland, they work on a vector tree position, so you can manipulate the position of the doors by changing the vector position. So in this case, 4 1 3, 4 represents the square 1 2 3 4, and 3 1 2 3,
Yes.
and 1 represents the z
Right.
axis. Okay, so if you change it to 5, you can see the door flying upwards.
Okay, I see. You can see the shadow.
Yeah. Okay, so bring it back to 1. So it's now like this. Okay. Okay, so now we want to rotate the door, right, towards the direction
Yes.
of the entrance. So in this case, for rotation, we'll put in the rotation the rotation properties. So so it's quaternion dot e Euler. So 0 90 0. So we want to rotate 90 degrees.
Okay.
See, so it's now rotated 90 degrees. Okay, so now we want to position the door near the entrance. In this case, then we'll change the position of the coordinates,
Coordinates.
the x-axis. So let's say, so in decentraland, right, there are 16 squares. Each square represents 1 meter. So that is the
Yes.
dimension you must also specify in your SketchUp model, 16 meter by 16 meter. So anything beyond 16 meter, decentraland will not accept it. So let's change it to maybe 15.
Can these coordinates be in the fraction?
No, you have to do it in code. Yeah,
Okay.
so unfortunately it's code based. Alright, so 10 looks like looks like a good coordinate. Okay. So now we adjust the y. The y, let's put it 15. Oh, there. So it's just about there. We can adjust the y some more. 15.5. Okay, but the door doesn't fit the entrance, right? So we need to um, expand or make the door bigger. Okay. So in this case, right, to lengthen the door or to make the door bigger, we'll be using door L component. Yeah, the scale. Okay, so the scale is what determines the size of the door. Is yeah. So
Okay.
now the scale is 1.1, 2, and 0.05. So let's say if we scale it up on the y-axis to 3, you see, so it's now bigger, and I mean taller, and we can scale it up. Let's say here 1.8. Oops, yeah. Okay, so we might want to shift the door a bit, right, down. So
Yes.
15, where is it? Yeah, there you go. So maybe 15.4. There, so we have a door here, but the door doesn't do anything. It's just a door to block the pathway, so I can't enter the building.
Okay.
So it's very technical, yeah. Yeah, so So basically, this is how decentraland programming is really is. So the components are programmed with code types in TypeScript, and the code describes the behavior of the component. So there's really two parts to decentraland: the building itself, the model, and the components. Okay. So now the next part is we
Okay.
want to toggle the door to make the door. We want to get the door to slide in and out, right?
Accessible.
Yes, correct.
Okay.
So looking at the code, right? Um, where is it? Okay, let's add this first. Open, close. Open, close. Okay. So what this does, it adds the pointer down event handler. So when the mouse goes down, it will toggle the state of the door, and it will also show the open close text when I hover the mouse over the door. Let's go back here. So you can see open close.
Yes.
Yes. So you can of course change the text. You can say you can put it like for go away, for example.
Can we put some symbol instead of text?
Yes, we can. That's a custom dialog that we have to program into the action. Yeah. Yep.
Okay. We will do that.
Yeah. So we can change the text, feedback text, to whatever we want. Yeah. So right now here we have a simple door. We can now go in and we can go out. Yeah. And of course you can put like a texture on the door. You can put whatever you want. Yeah. You can even put
Can we make it automatic doors?
yes, you can. So you can detect the presence of the character and slide the door open. So
Yeah, that will be great.
yeah. So I hope this is something that you're looking for. Some programming bits.
Yes, sir.
Okay. Um, okay. So Abhishek. So now we have covered
Yes.
the importation of GLB models into the decentraland test environment. We have also covered sliding doors as a simple demonstration, and we also positioned the door just by the entrance to demonstrate that it is possible to use coordinates to position your components to where you want them to be. Okay,
Yes.
so any questions from you? Anything you wish to raise or any doubts that you want to clear?
No, I think this we have learned enough for the start, and we can go in next video about the advanced steps about the doors and other things.
Okay, okay. Okay, so I guess this has been a fruitful conversation for you. I hope it has helped you a fair bit. Maybe it will help you to get ahead
Yeah.
with the project.
One thing, can we make the bulb glow?
Yes, we can. We can. That's also programmable. Yes.
Uh, is that simple step? If we can
Maybe
do it.
I'll do a next video tutorial on that.
Sure, sure, no
Yeah,
problem.
I think it's a fantastic idea. Okay.
Yes.
Okay. So
So basically, we can do anything in this uh, with the code.
yes. I mean, it depends. It's really up to your imagination. You can stream videos. You can put components. You can program games in it. Yeah. So this is really like a new client. So now we have like mobile apps. We have the web platform. So Decentraland is another point of interaction for people to interact with systems and and buildings and components. Um, yeah.
And I think it is in the baby stage. It will grow very fast in coming future.
Yes. Yeah. So we can imagine that in future we have like big shopping malls. We can have schools. Probably be in Decentraland.
Yeah, I'm working for a school in Decentraland. I have project
I see.
related to school.
Okay. Okay. So is there anything else add? Anything else you wish to add to this conversation?
No, not now.
Okay. Eh,
I think this is very good for the first video.
okay. If that's the case, thank you for coming to our episode on the Decentraland series. Thank you for your time.
To you,
Thank you.
bye.
Bye bye.